Welcome to Demo Mechanical Engineering, Thermodynamics. This is MENG3130. We'll be working through problem 380 using Interactive Thermo. So we have some refrigerant R22 in a piston cylinder assembly. We start out at saturated vapor at 5 bar, then we go through a polytropic process with PV as a constant to up to 20 bar, and we're asked to find the work and heat transfer, and we're told that the kinetic and potential energy effects can be neglected. So going over to Interactive Thermo. So I'll start by setting our units. So I'm set to bar, SI. So we know offhand P1 is 5 bar, P2 is 20 bar. We know we have a saturated vapor at state 1, so I'm going to set X1 equal to 1. And then we can use our polytropic process, P1 times V1 equals P2 times V2. So we can solve that for V2. Once we have V2, we can use our lookup tables here. So I'm going to set 2 R22. So at P2 now I know V2 is a function of pressure and temperature. So I've solved for V2 here. Plugging that in to this will give me the temperature out, which is one of the things we needed. And so we've got that. Now we can find U2. Oh, I didn't need to write that out. U2 is a function of pressure and temperature. So grab that equation. We also needed U1, which I should have gone back to. There's U1. U1 is going to be... I'm not going to grab the whole thing, I'm just going to grab USAT of this. There we go. We have U1, U2, V1, V2. I think we're pretty close there. So the last couple things we need here is, we need our mass. We have half a kilogram, so let me give you that up here. So then our first law is going to be our change in energy, M times U2 minus oh goodness gracious, U2 minus U1 equals our Q minus our work. And our work here will be our mass times, this is a polytropic process with n is 1, so we have the P1 times V1 times natural log. And in interactive thermal, we need to have Ln as capital, and we take V2 over V1. And that should do that. P1, V1, yes. And that should solve. So we've got U2, we've got U1, we've got Q is what we're solving for here. We have M up there, W is there. So we should be good. So let's give it a solve. Oh, I messed something up. Let's see, what are we missing? Got 6 equations, several unknowns. So we have M given, P given, P2 given. And what do we end up with P2? Oh, I do have P2. What else am I missing? So I should be able to solve this for T2. So I solve this for V2. Great. That gets me T2. So P2, T2, P1, X1, I have those. U2 minus U1 times M is Q. Make sure we have, I think we're good there. V2 over V1. P1, no, I'm still there. What are we missing? V1. What do I know? V1, P1, V1. Don't. Oh, I need, that's what I'm missing. V1 equals, so we're going to get our saturated specific volume. That was the piece I was missing. There we go. So that should take care of us. Yes, so now we can solve that. If I go to solve, I get something wacky here. I get that and that. The thing we're missing is that this P1 needs to be in kPa, so I need to multiply by 100 inside of that work. And now let's see if that matches what I'm expecting. That was close. I think it's 100. Or is it 10? So 5. Oh, because it's kPa. There we go. Let's try. Does that match up? I don't think so. No, I think it was times 100. Right, because this is in bar, so 5 bar would be 500 kPa. So that gets me 500 kPa. Okay. Oh, and it should be half a kilogram. There we go. 0.5. Does that take care of us? Yes, there we go. Those are the numbers I'm looking for. So this should match what we saw previously in our by hand calculation. So we find some heat out of the system at 7.6 kilojoules, some work into the system at negative 16 kilojoules, and the trick there is we need to multiply by 100 to get this pressure in kPa in this equation. Our other units aren't consistent with that if we don't have that in kPa, at least for this one. So that should take care of it. So then you can save that or print it, whatever you want with that. So quick overview. We had our in state 1 specific volume we looked up from our pressure and quality. State 2 we found the specific volume using the polytropic relationship. Just plugging that into our properties, we could calculate T2. Using that P2 T2 we could calculate U2. U1 was a lookup, and then just did our first law with those values. So thank you for watching.